Okay, we will start circular patterns. So I hope you are okay with this varying sketch tool. Now we will look at how to apply circular patterns. So the idea is we have this cut here, and we want to get a pattern around this object. So we will look at how to do it. There are different ways of doing it. So I will start with the art file available in the folder 826. So I'm going to start this circular pattern tool. Now here also we have features, bodies, spaces, likewise different ways. So if I just use the feature tool, so I will just keep the cut here, and we have to give the axis, pattern axis. There are a lot of ways of giving the pattern axis. Here we have a circular hole here, so if you want you can enable the temporary axes here. There's a temporary axis tool and give this axis as the pattern axis. So this axis can be given as the pattern axis, or else we can select this surface, so it will be acting as an axis, or else we can give this angle as the reference. So it is also uh, like a direction, so we can use this angle either. So there are a lot of ways in this diagram. So if you don't have a circular hole here, luckily we have a hole here. So suppose if you don't have a hole, we will just suppress this. If this is the situation, if you don't have an axis here, you can create an axis. Otherwise, if you don't have an axis, you need to rely on the dimensions here, angle here. So I will just use it and show you again. Take this as the reference. So it's 360 degrees, equal space in 8 instances. So if you want, you can change this to 180 and change the direction this way, and remove the equal space in options and give something like this. So now it's 23 degrees, 5 instances. So 30 degrees. So this is not the equal space. If you press equal space, it is distributed equal. So other options are similar to these linear patterns instances you skip. Here also we have this uh, body feature, those kind of things. So if you have something like this kind of a model 828. Now here I don't have a middle axis, so if you just look at this, they have given the reference light is 45. So if you want to apply a circular pattern, just select the feature, this cut, and this is the direction. So you can use that direction method. Suppose you haven't put this measurement, you can use axis. So axis I have to create. So we have done this theory before, how to create axis in the middle. So you can easily use two planes method if it is a symmetric design. Luckily this is a symmetric design, so I have the middle axis in the middle. So I can create an axis and go to circular patterns here, select this axis and cut. Feature is this cut. So that can be also done without using this angle. So that is an additional thing I have to do. I have to additionally create this axis. So there are a lot of ways of doing this. Just try it and see. So we have to give the center axis and the angles and the instances and features or bodies, and we can skip the instances. I can get the geometry pattern, visual properties. Likewise, options are there. So you can try this and see. Any questions, let me know. So we will move on to the next tool, that is called the rip tool. So you may have seen in the designs, people are using these kind of supports to prevent the design to be failing from this edge. So when you apply a load, sometimes the design will fail from this edge. So to prevent that, we will give this kind of rip support. So these are called rips. If you want, you can just draw an triangle and extrude this. But it's easy if you use the rip tool. You need to just draw only one line and apply the rip tool. So we will look at how the rip tool works. #858. So I haven't done these methods of drawing the patterns because of time limitations. So I have done first three. So I'm now moving on to rib tool here. So I hope everyone can draw this kind of a line now. So this line was drawn in the middle plane. So if you have a middle plane, you can draw it in the middle. Say if I just quickly draw it, select the middle plane and go to sketches, make it perpendicular like this. Then use the line tool here from this point to this point. There's escape. So this is the sketch. Then we will apply the rip tool. So once you go to rip tool, there are different ways of getting the rip. One is parallel to the sketch, other one is perpendicular to the sketch. So this is parallel to the sketch, automatically selected. If you select the perpendicular to sketch, rip is forming this side. And if you try to press OK, nothing will happen. There's an error popping because you don't have boundary in this side. No boundary. So I have to use this one, and the arrow should be this side because this side has the boundaries. If you just flip the arrow to the other side, there will be errors again. So you have to have correct side to make the rib, and rib thickness is 10 millimeters. It's symmetric. If you want, you can have asymmetric rib also. And if you want, you can apply an angle for the rib. So if I just press OK, this is the rib. Now if you want, you can have a draft also for the rib. So I will increase the angle, say 4 degrees draft. So this is the outward draft. Then we can have an inward draft also, something like this. So it's going inside. Say I will do more angle. You can see how it inverts. Okay, so this is how the rig tool works, basic idea. So if I elaborate this, these kind of sketches also can be used to make ribs. So this is a rib to support this structure. So you don't need to connect these lines up to the boundaries. Automatically the boundaries will be taken. So if I just use show this file 860, now the rib has been already applied. So here we have the circular patterns, ribs. So if you just roll this down, this is the situation. So if you just start from the beginning, they have drawn this part. Then they have drawn the other base. Then they have drawn this. Then a hole here. Then one hole again. Then there's another circular pattern. Then third hole. Then fillets. Make it round here. So you don't need to draw everything at once. So this is a sharp edge, sharp edges. Then apply the fillet. Okay. Then they have drawn a plane to draw the rib feature. So if you just look at how the rib has been done, so if you just delete this, they have drawn the sketch. So you have to draw a plane. On top of the plane, you have to draw the sketch. So on the sketch here, we have to apply the rib. So just go to the sketch mode. Now you can see this is not connected up to here. If you want, you can connect. Anyway, this is going to extend. So we will apply the rib. So automatically the parallel tool is taken. Thickness is 10 millimeters. If you flip this side, nothing will form. Say for this, okay. There is no boundary. So flip this side, okay. It will get the fillet shape. So you can try these things and let me know any questions. You can just try this fillet tool and rib tool and this rib tool and check whether you are getting the outputs. So we will move forward. Here is another way of applying the rib. Now earlier we did parallel to sketch method, parallel to sketches. Here also parallel to sketches. Now this is an example of normal to sketch. So if you want to get something like this kind of an output, it's very difficult to draw extrude. Using extrusion operation is going to be somewhat time consuming. You have to draw all the double lines and extrude the sketches. So rather than doing that, we can draw only these lines and apply the rib feature. So I will show you how to get it from the rib feature. I'm using this available sketch 8 model 862. So we don't need to draw double lines like the extrusion. So we can just draw these single lines in a single sketch. And in the sketch mode, I can go to rib features and give a thickness. Automatically you will see the normal to sketch is working. That is, this is happening normal to the sketch. Rib forms normal to the sketch. You need to just press OK and it will automatically extend up to the boundaries. Now this will OK. You can see it's automatically going up to the boundaries. So that may be a weakness in rib because rib always tries to find the boundary. So that's why it's going up to these boundaries automatically. So you cannot stop it at exactly here. So sometimes you may need to apply cut tool and manually cut this. So that may be a weakness in rib feature because it tries to find the boundary always. So if you want to form this kind of a puzzle or something like this kind of a shape, maze, this is easy. So I need to just select the rib, the sketch and adjust the thickness. If you select the parallel to method, it won't work. So here it doesn't start. So parallel to sketch will not work, normal to sketch will work. And it says it's a linear type, that is your lines are straight. But if you look at this diagram, this is a circular shape. So you are getting this kind of curves. So this is a natural shape. So if you just select the linear shape, this will be the result. If you select the natural shape, this will be the result. So I will show you that diagram also. Next one, 864. So if I apply rig for this sketch, normal to sketch will be automatically selected. There are two ways, linear or natural. If you select linear, your ribs are something like this. So it will go up to this boundary and up to this boundary and finish. So probably this may have been drawn first, then this may have been drawn. So it stops here and this one is going up to here, second line is this one. So if you just select natural method, automatically the natural curvature will be taken. So this will be the output. So these tools are not really very flexible. You have to be careful when you do the sketch. So that up to the designer who is doing the sketches to make sure you are getting the natural or linear shapes. So you can just try these things and see whether outputs are appearing. That is the difference between linear and natural. So this is the linear appearance. This is the natural appearance. Sometimes these shapes may vary in your computer depending on the versions. So I'm not getting this shape anyway. So if I just put natural, my one is stops here. But if you look at the slide here, it's getting the curvature correctly. So sometimes this line may not be enough. That's why I'm not getting it. So this curvature may not be enough. So we can expand this one a little bit further and try to get that circular shape. We will try it and see. So all depends on the drawings you have done. Still my one is stopping here. So I think the curvature is not enough. No, not enough. So you can try these things and see. Any questions? Let me know. So we will look at the next section. The next section is about next section is about creating 3D sections. So if I want to look at the inside of an object, this is not actually generating drawings. This is about just cutting the pins and see inside. So if you want to look at the inside of this object, just use this section tool here, and now it will show me the inside of this object. So I cut it in the horizontal manner. So you can cut it from front plane or top plane, likewise, or right plane this way, and adjust this sectional length also. And if you want, you can rotate the section even this side. So color can be changed, and if you want, you can cut it from another section, like front plane again. So I have cut it in two ways. So front plane and right plane. Now you can cut it in another plane if you like. Section 3 can be also incorporated, say top plane. So there are a lot of ways of cutting the things, and if you press OK, now this is your section. It's not appearing in the design tree. If you want to get the full model, just untick this button. You will get the full model. So this is just to get a visualization only. This is not a drawing. So this is not a manufacturing drawing. If you want to get manufacturing drawings, you have to go to drawing areas and generate the section. So we haven't done these areas. We may not be able to do these areas in this limited time. So for the time being, you can just cut it like this and see how it works, how it will be shown before the manufacturing. So just remember this tool also, and untick this, you will get the full model. So this is a small topic, changing the display states. So if you expand this design tree, you will find these transparency buttons, display mode button, those kind of things. Now here, if I want to make this model a transparent model, just click on this. It will be transparent. So quickly I can make it transparent. If you expand this, now you can. This is the normal situation. You can expand this and come here, and this column is for the transparencies. You can just do this way. So you can apply transparency for the shape, apply the transparency for this. So quickly we can change the settings, and we have done this edit appearance earlier. We can go to appearance tools and give a color for that. So these things I have done earlier. Quickly we can give it a color for this also from here. So and this is show hide buttons. We can hide the planes, we can unhide the planes likewise. This can be used effectively. So if you want more space, just click on this small button here. You will get more space in the drawing name. Or else you can hide this display plane from. So just observe these things and just try to use these tools effectively when you do a design. So you can have nicely colored drawings, models in SolidWorks. So try this tutorial number 1. Number 2, I will do it with you. Any questions up to this the theory part in chapter 8? Any questions about patterns, ribs, and mirror tools? So this is the model I should get. From these 2D manufacturing drawings, we can generate this kind of 3D model. So if you look at this model, this is a circular shape. So if you want, you can draw these circles. Say outer circle is 42, then there's another 140, 34, 12, likewise lot of circles. So you can draw this full one and cut the inside here, or apply the shell tool. Then we have to draw the rib and apply circular patterns. We have to draw these brackets here and apply these hole tools. So a lot of things can be done. So if you just critically think about this drawing, you don't need to draw a lot of cylinders. Since this is a circular shape, we can get the usage of this section. So if you just look at the section here, this is the part I should draw actually, and you can apply the revolve. So that's what they have done here. They haven't drawn several circles and got the extrusions. They have just drawn the section here, this section, and got this from the revolve tool. So we have to draw this part only, this section, and apply the revolve. Otherwise, you have to draw a cylinder here, another cylinder here, and cut the cylinder and cut this middle part. A lot of cutting should be happening. Without doing nothing, we can just draw this kind of a section and get it. So how to think about this section is from this sectional drawing. So that's why they have given this sectional drawing. So you can use this sectional drawing here for this part and apply the revolve. So sometimes from drawing the cylinders also you can get it, but this is much more faster. So I will use this one and get this shape quickly. So I hope you understand what I'm saying. So rather than drawing the cylinders and cut the materials, you just draw the section, apply the revolve. So we will do this. I hope everyone can manage this kind of work now. So I will start the work. You can also start. Get a new file. This is our chapter 8 tutorial 2. Better you save your work. Sometimes SolidWorks crashes. So you can use any planes. I will use one plane. We have to draw this shape. So origin is here. Say origin is here. So we will just draw a rough sketch and adjust the measurements. I will apply dimensions. The far most is 42. So I hope everyone knows how to get these double values. So if you try to put 42 in my one, there will be sometimes problems. So now it's okay, this adjusting 42. If the drawing is getting distorted, don't apply 42. Come from the inside dimensions. 42, this is 40. Then 34. Okay. 42, 40, 34. Then this is 20. This is 12. And the other one is 10. This one. So I think my center origin is not going through this. So we will just draw a center line going through the origin. And make sure this is overlapping with the collinear with the origin horizontal line. So then it will pretty sure. 42, 40, 34. So I have some blue lines here. 1, 11, 10, 12, 20, 34, 40, 42, 1, 2, 3. All the lines are marked, but I have a blue line, several blue lines. We'll ask the software to make it fully defined. Now it's fully defined. Now it's fully defined. So we can apply now the revolve. So we will take this axis and apply the revolve tool. You can get the shape. So just try this thing and let me know any questions. So I'm getting the bottom shape also from the revolve. That's the beauty of using this method. Otherwise you have to draw this separately, this one separately, cut the material. So a lot of things have to be done if you don't use this straightforward method. Any questions about this? Now after we do this one, it's very not very difficult. You have to draw the brackets here. So I will show you how to do it also. So I will try to draw the side bracket here. So the sketch is simple, you don't need to worry much. So we can take the bottom shape here, go to sketches, if you want to make it perpendicular like this. Then draw this shape. So if you want, you can make it hidden lines visible. And we have to draw all these center lines again to make it centered. Now this radius is 5, that way there's a circle of 10. So I can just draw a circle here, outermost here. Uh, this is radius 10, diameter, radius 5, diameter 10. Then this is going up to this boundary. So if you want, you can convert this boundary to a line. So I will use convert entity tool and select this one and convert it into a line. Now this is a line. Then we can just use this quadrant here and extend these lines here. If you want, you get a mirror, or just offset this one also. So I'm getting quadrant snaps here and getting up to here. Then we can trim. So I got the shape like this. So I converted this line, this edge, to a line using the convert tool. Last week we discussed this and got the shape here. And the height is 3 millimeters. So we will have to extrude this 3 millimeters. This. I think I didn't use this one R50, so I have a problem. I think. We'll check. So I have a problem. My design is wrong. I have to first draw this R50 and do this design. So I will undo this. I made a mistake. So first we have to draw this 50 circle because this bracket is somewhat out of the path. So otherwise you cannot drill the hole here. So we have to make sure we are doing correct designs. So I will do it again. We can use, we can draw this 50 circle first, make it a construction circle. Then this should be 50. So always try to get the drawings carefully, otherwise you will have problems in the 3D model. Then we will draw the center line. Then on this one we can draw the circle here.
Excuse me, sir.
Hello.
No. I got the revolving part, but how can I got that? How can I get that red arrow, the center?
This one.
Yes, that one.
It's here. It's in the origin here. So when you
But after the revolving, yes.
uh, yeah, when you look visualize this way, it will be centered in the middle origin. So this origin is here in the bottom. exactly here. So when you turn this model and look at from the plan view, you should get the origin in the middle nicely, because this section is symmetrical around the origin. So I'm revolving this way.
Yes, I revolved around that axis, but after revolving, it disappears.
When you turn the model this way, plan view, can you see it? Now I can see my
No,
origin here.
no, no, I can't. I can't see that.
If you cannot see, no need to worry. Just draw a center line from the center of the circle and get the sketch. If you cannot see it, sometimes you have to come and check these buttons, whether this is off or view origin tool is working. Just check whether these are off or on. These tool should be on. So these,
Yes, now I can see that. Yes,
yeah.
it should be on.
Uh, Now it's 10 here. Make sure this you draw this line, this circle. This circle should be a construction. Why I'm saying that? Otherwise, you cannot extrude. If you do this kind of a continuous circle, there will be problems in extrusion. So you have to make sure this is construction. So just press the construction button. It will be drawn as a construction circle. So otherwise, there will be problems in when it comes to extrusion. So draw this circle. Then, if you want, you can offset these lines 5 both sides. So I will use that method now. Just give a offset value bidirectional, this one. So that can be also done. Yeah, rather than drawing two lines, you just offset 5 both sides at dimensions, both sides bidirection. That can be also done. Then trim. Before trimming, we have to convert this boundary, this line to a boundary. So this boundary to a line, sorry, convert entities, this boundary to a line. Now I have line here. I don't need to draw circles again. So I use the convert tool. Then we trim. Sorry, you have to use trim tools. So if you have done it correctly, you should be able to extrude this. Uh, Sometimes we have to select contours manually. So this thickness is 3 millimeters. I am getting a problem. Problem are these. So if you just look at the sketch, trimming hasn't happened correctly. So be very careful when you apply the trim tools. So these things comes with the experience. So you have to quickly understand there is something wrong with the sketch. I have to do. I have to go and edit, check the sketch. So when I check my sketch, I find that some lines are not cut properly. So these there are problems in this area. So it should be a nice close loop. That's why you don't get the extrusion tool working. Now it should work. If the preview appears, it should work. So quickly understand that my sketch has an issue. That's why extrusion tool is not working. Especially check the corners, the connections, the coincidence, the tangent operations, all these things. Now I got the bracket. So I have to have 3 brackets. In the drawing it says 3 brackets. So we can actually cut the hole and get the pattern, or else you can pattern the brackets and cut the holes later also. So there are a lot of ways. Here they have used the hole properties given here. So I have a 3.6 diameter hole, 6.7 diameter holes. Two holes are there. So 3.6 diameter hole depth is not given. 6.7 diameter hole, the depth is given as 1.65 and the bottom is flat. So if you want, you can use a hole wizard tool, or else you just drill by yourself manually. So if I try to do manual methods, the first hole is 6.7. The big one is 6.7 and its depth is 1.65. So you have to select this space, go to sketches. If you want, you can use the simple hole method even. I will just draw a circle. This is a simple one. Just click, hover over here, you will find the center point. You just hover over the mouse here, you will find the center point. This diameter is 6.7. So this is 6.7 in diameter and the depth is 1.65. So I can cut it, a blind cut, 1.65. If you want, you can apply a revolve cut and do it in one operation. Draw the section and apply the revolve cut and do it in one operation. I am doing it in two operations. Always use hole wizard if you know the hole properties correctly. Now I cut it 6.7, 1.65 depth. Then there's another hole 3.6 diameter. So you select this one again. I'm not using hole wizard, I'm just using normal method. This diameter is 3.6. In the tutorial they are using hole wizard. I don't have that hole properties at the moment, so I'm using this normal methods and cutting. 3.6, and this is a through hole cut. Through hole, no, you can say up to next. It will cut like this. So I hope you understand how to read this draw. Read this. This says the bottom is a flat surface. So I got the bottom as flat. 6.7 diameter. 1.65 depth. So you drill the thing up to 1.65, then come to the small hole. It's a through hole. It doesn't give the depth. That means it's going through hole. So that's it about the bracket. Then we can pattern the bracket here with the hole. So I will use the circular pattern here. Axis, maybe luckily I have the circular surfaces, so we can quickly select that. And features to pattern is this boss extrusion and this cut and this cut. And this, I have three entities. Quickly we can get a circular pattern. So you can try up to this point. Any questions, let me know.
Three x and diameter is says that 3.6. But what's the 3x?
3 axis, you have three holes here. So you have one here, and one here.
Oh,
That is actually not needed for the drawing. That meaning is you have to have three holes. In the full drawing, you have three holes. Here also,
then what's the 6.7? The diameter says 6.7.
6.7.
Yes.
6.7 is the big one. Here we have
Okay.
big hole 6.7, and its big hole is 6.7 and its depth is 1.65 here, and the bottom side is a flat surface. So this is the mark for the flat bottom. Then we have 3.6 hole here. We have three holes like that. Actually, you have to write three times here also. This one also should be three times. So both are three times. Here also they had said three times R5. That is, you have three brackets here R5. So if you are finished up to this point, next is to draw the ribs. So we will look at how to draw the ribs later. I will give you some time, just try this thing.
How did you connect that R5 circles uh, to the main line, main circles?
R5 is this
Yes. Two small parallel lines
parallel line. So
connect in R.
you can you have the center line here, so you can offset the center line both sides. Say I can use the offset tool, put 5 here, bidirectional, and select this one. So you will get two parallel lines. Then you trim the unnecessary parts and get the correct shape. Like in OS, you draw two lines manually, one by one. Then you can get these two parallel lines. Then I use this convert entity tool to convert this boundary to a line. So you can select this one and convert it to boundary to a line. Then you get a line there also. So that's how I did.
Okay, thank you.
Now I have to draw the rib here. So you don't need to draw all the ribs. You can draw only one rib and make a circular pattern. So when you want to draw a rib, what are the easiest ribs to draw? So easiest ribs to draw will be this horizontal rib. So you can draw this side or this side, because these sides I don't know the angles. I don't know how to calculate the angles. So I can draw this rib, and the rib thickness is 2 millimeters. So if I have a plane going in the middle, it's going to be easy for me. So I will just check whether I have a plane. Say, mm, so I should have a plane in the middle like this. So if I look at my planes here, uh, this may be useful, or otherwise I have to create a plane, horizontal plane. So how can I create a horizontal plane? If I can use this one, it's going to be okay. My drawing is not really symmetrical. So I don't know whether this is correct. So we will try to make it perpendicular. So this way. Now this is the exact shape. So I will just check my planes. I have a plane. So front plane is there, lucky. If I don't have a plane, I have to create a plane. So we can use those plane techniques and do it. Luckily, I have a plane like this. So now this plane can be used to draw the rib sketch. So I will select this plane, go to sketches, and make it perpendicular to the screen this way. And you have to unhide these things and see the inside. Now you have to draw this shape. So if you elaborate the drawing more detail, they have given it separately. Actually, you have to know how to read the drawings and draw these things. Now this shape should be drawn, this line. So I can easily draw a line from this edge here, this point to this way. So when I do this way, what happens in the middle of the drawing, you are drawing something like this. So from here to here, I'm drawing a line. So I have to have a plane in the middle. Then rib thickness is given as 2 millimeters. So I will expand the screen. So I have to draw a rib 2 millimeter thick. So this is 2 millimeters. Material should go inside. It's a parallel one, automatically it's taken. Press OK. If you have done it correctly, you should form a rib like this. Okay, so I drew a line from here to, from this edge to this edge. So just expand this and see how it has been done. from here to here. And luckily I had the plane in the middle. Then after we get this, we have to apply the circular patterns. So it's easy. So you just select this, and feature is this feature, and I have six. I think six. So just check whether you are okay with this one. Make sure you select the middle plane. Draw a line from here to there, and apply the repeat and save the model. So this is the final model. You can try this question at home. We will start the next chapter. I don't have much time to give in this 4 hour session. So I will start the chapter 9. This is a small chapter talking about the editing tools in SolidWorks. Actually, we already know about this, most of the editing tools in SolidWorks. So we will look at some more features available in the software. So, as you know, when you want to edit some models, there are two ways of editing the model. One is you can go to sketch level here and do a sketch level editing. So I can go to sketch level and do a change in the sketch level. Or else otherwise I can go to feature level and do a editing. So you can edit the 3D model, or else you can edit the 2D sketch. So if you do a lot of designs, big design, you may want to rename these features. So you cannot have boss extrude 2, boss extrude 1, cut 1, cut 2 like this. Better you rename this one using, there's a tool called feature properties. So if you want, you can right click on this feature and go to feature properties here and give a meaningful name for this. Say I can give a bracket, something like this. So I can give a description about this, and these time stamps are automatically saved. So bracket is given as a new name. So now you have a meaningful name in your design. So when you do a big design, better you have names for your features. Otherwise, it's very difficult for someone else to read these things and understand. So you can edit a feature from these tools. So we have the suppress tool available here. We have done this before. So when you suppress this bracket, all the things related to the bracket will be suppressed. So you can unsuppress the bracket from this tool. So only the bracket comes, others are not coming. So you can unsuppress one by one. So these are the children. So all are dependent on the bracket. So these circular patterns all are dependent. So if you try to delete this bracket here, all the children will be deleted. See how it works. So if there is a parent-child relationship in Solid. So if you try to delete this rib here, the circular pattern will not be there. So remember that. So if you try to suppress the rib, others will be also get suppressed. If you unsuppress the rib, only that will be unsuppressed. The children will be still suppressed. So yeah, I hope you understand the difference between suppress and delete. So if you delete it, it's permanently deleting. Suppress, you can temporarily hide and unhide. So hide and unhide is different from suppress. Last week also I told about these tools, the difference. So try to remember this one feature properties tool to make it rename, and you have transparency tools, some other set of tools. So if someone's make a mistake in their working plane, so there's a tool to change the sketch plane. So you can always change your sketch planes later. So if someone finds my sketch plane is wrong, I have to put it into some other plane. You can right click on this, and there's a tool called edit sketch plane. So this may sometimes collapse your other parts. So you can try it and see. I don't like front plane. I will put it into top plane. So everything will be now going to be in top plane. Now I have an error popping up. Some sketches are not working. So rib feature is not working. So because rib feature depends on the plane top plane. So you can do those changes. But remember, if you do it for the very beginning features like this, these children may get affected. So if you want to change the rib plane, edit sketch plane, and without front plane, I will